Okay, so complements is the last part we have to cover for right now. So complement events. So the complement of an event E is a set of all outcomes in the sample space that are not included in event E. So what that means is that anything that is not the event happening is the complement. So the notation for a complement of event E is we write it like this. PE in that little dash, so that's an E prime. Or we write it with this little C to mean a complement. The other way, this means a complement event. In your booklet, it sounds like this one, but the other one's very common as well. So sometimes a complement event is called the not event. So if we were looking at, say, dice rolls, and we're looking at our sample space, if the event of interest is the event of rolling a 4, so this is event A, then the complement of A is going to be everything else. So that would be the complement. So if event A is rolling a 4 on a dice, the complement of event A is not rolling a 4 or rolling a 1, 2, 3, 5, or 6 on a dice. So complement is anything else that could have happened. So sometimes you can think of this as like your opposite event. Okay, so 200 students were enrolled in a stats class. We want to find the complement of the following events. Exactly 50% of them are sophomores. And the complement of exactly, so this means exactly is going to be 50%. The complement of that was that the number of sophomores is anything but 50. Oh, sorry, let me try to figure that again. Exactly 50 of them are sophomores. So I was right the first time, was just the X. So we got exactly 50. So the complement of that, like we said, we have anything but 50 sophomores. Anything else, the complement of the number of sophomores is just not 50. More than 50 of them are sophomores. So that's over 50 are sophomores. The complement of that would have to be, well, then less than 50 or 50 would have to be a sophomore. Because it has to be the complete opposite. If over 50 are sophomores, then that means that the complement of that event is either 50 are sophomores or less than that are sophomores. If at least 50 of them are sophomores, that means this, 50 or more. The complement is that fewer than 50 have to be sophomores. So when you're thinking about complement events, this is kind of stuff you have to think about here. Oops, let me write that again in blue. That if one event is equal to some number, then the other event is anything but that number. If one event is more than, then the other event has to be less than or equal to. If one is more than or equal to, then the other one has to be strictly less than. Well, these are the kind of things we have to think about when we're thinking about complements of events. This is a little something that we're going to see a little more later. So our complement rule. So if we have the probability of the complement event is going to be just 100 minus the probability of the actual event. Another way to think of this is the probability of event A and its complement as 100% because it represents 100% of the things that can happen. If we want the probability of A, we could find that by doing 1 minus the probability of the complement. And this one's actually, we use this quite a bit to help us describe events that we might be harder to calculate going directly for the probability it could be actually easier to calculate the complement and then come back and calculate the actual event. For example, according to the Wall Street Journal, 40% of cars sold in recent years were small cars. The probability that a randomly selected sold car is small. I think it's rephrasing there. For example, the Wall Street Journal said 40% of cars sold in recent years are small. The probability that a randomly selected car that is not small. So if we want to figure out the probability of randomly selected car is not small, we just do 1 minus that 0.4. We get that 0.6. So this is all my small cars, and these are all my not small cars. So the complement, the probability is just, like what's left over. So 40% of cars are small. That would mean that 50%, 60% of cars are not small. And that's what we call these not events times. A company is conducting a survey of randomly selected individuals to determine the ages of social media application. So far, 3,000 users, we saw this already, 3,000 users of the application have been surveyed. The frequency distribution shows the results. We want to know, what is the probability that the next user surveyed is not 25 to 34 years old? We had already found this before. So this is being 25 to 34 years old. So this probability, we found it out last time, is 765 divided by my 3,000. And we got 0.225. So 22.5% of this population was between the, let's try this again. 22.5% of those sampled using the application between the ages of 25 and 34. So if I want those not in that age group, I could go through and I could add everybody who's not 23 to 34, or I could just remove them from the total group. So not 25 to 34. That just means I have to take 1 and remove the probability that they're from 25 to 34. And that probability is 0.225, which is going to leave me with 0.775. So what we have here is 77.5% of this population here is not between the ages of 25 and 34. Like I said, if I had managed to sum up all of this, I would have found that same information. Because if I summed up all these numbers, these are all the people who are not between 25 and 34. That would be 2,325. You're still going to get that same probability. So like I said, knowing the complement probabilities sometimes makes our calculations much faster and easier. So this is something that you may end up seeing again. So we have at least one event. So previously we looked at a scenario of tossing a penny and a dime and a nickel. If event A is tossing at least one head, another way to, okay, let's say there was a typo. Event A is tossing at least one head. That's the event we're looking at. Another way to phrase this event is tossing one head, two heads, or three heads. The one thing that's not covered under at least one is no heads. So the only outcome that doesn't fall under at least one is no heads. If I wanted the probability at least one head, I just need 1 minus the probability to have no heads. The complement of at least one is always going to be the event of none. So if I want the probability at least one thing happened, that is just going to equal 1 minus the probability that the event did not happen at all, none. So we really use this in much more complicated scenarios, especially like when we do binomial probabilities. So we're going to assume, because this is not 100% true, actually, there's slightly more baby boys born than baby girls, but we are going to pretend that the sex of a child at birth is equally likely to be male or female, 50-50. Like I said, it's not 100% true, but we're assuming that right now because that's the probabilities that we can handle. What if we randomly select a woman? We randomly select women with 3 children. What is the probability that at least one child is going to be born male? Okay, so our sample space is going to be this. I can have all boys. I can have a boy. Then I could have had a girl. Then I could have had a boy. I could have had a boy, then a girl, then a girl. I could have had a boy and a boy, then a girl. I could have had a girl, a girl, a girl. I could have had a girl and then a boy, then a girl. I could have had a girl and then a girl, then a boy. Okay, make sure I didn't miss one here. Or two, two, two. No, I've got them all. And the other probability is I get a girl and then I have 2 boys. So this is my sample space. So I want to know, what is the probability that at least one child is going to be born male? The opposite of that, the complement of that event would be the probability that there are no males. And we only have one event where we have absolutely no male children. So if I wanted to figure out the probability of a male, all I have to do is do 1 minus the probability of no males. So 1 minus, we have 8 outcomes, 1 out of 8. That means 7 out of 8 have at least one male. Okay, so it may not have been necessarily to do this one with this example here, but just to get us ready for the future, that when we're talking about at least one, sometimes easier to do the complement of none.